Hello everyone, welcome back to the another session in design and analysis of algorithms. Topic name is branch and bound. This topic you will find in 4th unit topic number 5. Now, the contents of this video is we'll be going to talk about what is branch and bound and what are the different strategies of branch and bound. Now, let's get started. What is branch and bound? This is one more problem solving strategy similar to backtracking. So in the sense that it uses a state space tree for solving a problem. So now the state space tree in backtracking is constructed using DFS approach, depth first search. But the state space tree what we are going to generate in branch and bound uses BFS, which is breadth first search. And so the third point is it is an optimization problem. So we are very much aware of this optimization problem from the previous units. So optimization problem is what? The solution of this any problem will be either maximum or minimization. Then the problem belongs to optimization problem. But as far as branch and bound is concerned, the problems are optimization. The result is always expected in minimization. Minimization, not maximization. And so we'll be going to use a bounding function in this. The name itself it suggests us in this. So branch and bound in the sense we'll be going to construct a tree where each tree will have some branches. That part we'll see. So here the branch in the sense which part of the branch is going to get explored. Exploration of a branch. And bound is what? Bounding function. Now we'll be going to talk about bounding function. What is bounding? A branch and bound method searches state space tree using any search mechanism in which all the children of the E node are generated before another node becomes the E node. So this E node in the sense exploring the node, exploration of node or exploring the node. Now we'll see some example to understand this problem. And we assume that each answer node X has a cost C of X. Now let's see some example that I wanted to make these three people sitting together. Okay. So what I'll do is I'll make A, B, C in one row. Now, so you might have noticed the constructing of state space tree. If it is using backtracking, then we used to generate the E node, exploring the node depth wise, right? But it is backtracking. Now it is branch and bound. In the beginning of the video only, I told you branch and bound uses BFS. And that's what A, B, C are together. Now if I wanted to explore this node, I have a choice of exploring the A node or B node or C node. So based upon what we'll explore, that is what it is having three different strategies to explore E nodes. And those strategies are FIFO method, LIFO method and least cost branch and bound. FIFO, first in first out branch and bound, last in first out branch and bound, least cost search branch and bound. So these are the three different strategies using what we will be going to generate the state space trees. Now a cost function C such that C of X less than or equal to C of X is used to provide lower bounds on solutions obtainable from any node X. If upper is an upper bound on the cost of minimum cost solution, then all the live nodes X with Xc of X greater than upper may be killed, as all answer nodes reachable from X have cost C of X greater than or is equal to C of X greater than upper. The starting value for upper can be obtained by some function or it can be imagined as infinite. So the starting value for upper can be infinite, value can be infinite as we are not known it. So clearly So long as the initial value for upper is no less than the cost of a minimum cost answer node. The above rules to kill the live nodes will not result in the killing of a live node that can reach a minimum cost answer node. Each time a new answer node is found, the value of upper can be updated. Now we'll see some example to understand this. Now, so we'll discuss about those three strategies: FIFO branch and bound, LIFO branch and bound, and least cost search branch and bound. We'll talk about that. For that, I'm taking some example. This example is what? Job sequencing with deadlines. So we are very much familiar with this job sequencing. Now, assume that you are given with some number of jobs J1, J2, J3 and J4, and you given with the profits also and the deadlines also, where it is 10, 5, 8, 3 and deadlines are 1, 2, 1, 2. Now understand this, that I have to find the solution for this problem to know what jobs are going to be part of the solution. Now, there are two types of generating the state space tree solution for this problem. That can be in two types. One is variable sized and the other one is fixed size. So variable size in the sense the solution will be S is equal to J1, J4. It is what? Variable sized. Fixed size in the sense S is equal to 1, 0, 0, 1. So this one is what? That J1 is available in the solution. J2, J3 are not available. So we did not mention with the 1. We mentioned with the 0 as to make sure that these are what? Null values. And this is J4. According to this solution, I made this solution, that also 1. Now let's see how to generate the state space tree, or else how to explore the nodes in the state space tree. Now I'm going to construct this state space tree 1, 2, 3 and 4, 5. How many jobs we are given with? We are given with J1, J2, J3 and J4. Now, so which node I have to explore? This is what the biggest question in this branch and bound. So branch and bound says that you can make E nodes. Okay, and you'll use bound function when C of X is greater than or equal to C. Cost function of 1, if it is greater, then we'll kill this node and we'll go to the other node. So now it is J1. So I told you that it is of BFS, right? Now in breadth wise we'll be going to find the job solutions. So if I wanted to explore this node, already J1 is presented. So which nodes will be going to take into considerations? J2, J3 and J4. This is J2, J3, J4. Now it is exploration. So now if it is exploring at third level, already J2 is there. So you have to find it as J3 and J4. Okay. Now, so already it is J3. You have only one chance that you can place only J4. That's it. Now, anyhow it is J4. There won't be any choice of placing the other job. So, 2 jobs were completed. Still you have a chance of placing the jobs. So, it is J3. And the other choice is J4. So already it is J3. You have only one choice of taking the job, which is J4. So already it is J4 and that's what I am not going to explore the node. So it is J3. So I can also have some J4. So I am just making it is 15 and it is J4. Okay, it is J3 only. Still you have a chance of exploring, which is J4. So now this is what the solution for which method? For FIFO method, first in first out. The data structure what we will use is Q we will use. And the next method is LIFO method, last in first out branch and bound. For the same problem the solution will be going to give using sets method. So that is we will take in this way. Now what we will be going to do is we'll take the nodes J2, J1, J2, J3, J4. Now again from this you have to come, because it is LIFO. You will maintain stack over here. What are there in stack? 1, 2, 3, 4, 5. The last node is what? 5. The first node is what? 5. Now you have to explore this node, but you don't have any chance, right? It is already J4. You can't do anything. Now pop from the stack. Now it is 4. Now it is J3. Still you have a chance of placing the item, which is 6th node, but it is J4. Now it is J2. Now again it is J3 and J4. It is J1. It is J2, J3, J4. And it is again J2. It is J3 and J4, right? So you have one chance over here. So now with this, what you have understood is you can place the jobs in your state space tree. Now we'll see about least cost branch and bound. In least cost branch and bound method, the state space tree will get started with C is equal to infinite value. So that means upper value is equal to infinite, and from the node 1 we will be going to expand all other nodes. Now one node will get expanded to 2, 3, 4, 5. For each job to complete, we'll take some cost. So I'm just giving the example over here to understand how LC method will works. Now here, so to complete J1 task, the cost is $25. To complete J2, $12, $19, $30. Among these four, whichever is least cost, that will get expanded again. Now out of these four values, 12 is the least cost. So now this node is going to be expanded. Now again, this is whichever value is least, that value will be considered. So this among 16 and 7 is the least one. So this is going to be considered. Now it is already J2, correct? So now you have only 2 tasks to get completed, J3 and J4. It's already J4, you cannot expand this node. If it is J3, then you have to expand this node as it is a least cost. So this is what least cost branch and bound method, right? Now thank you all.